Hello, here's a short nudge video related to the light and color mop number 6 on the primary pigments. The kinds of questions you're going to see in this particular mop are a lot like the ones you saw earlier in the mop about the primary colors of light. I do want to reinforce that when you're asked about the primary colors, it's important for you to know whether you're talking about the primary colors of light or the primary pigments. So those are going to be different things, and just make sure you're looking closely at the questions. And they are related, of course, to each other. So just to quickly review what you know about the primary colors of light, and it's shown here on the figure on the left, when you have, let's say, green and red light simultaneously shining on a white piece of paper, it will appear what we call yellow, because that will stimulate the two particular cones in your eye that cause your brain to say yellow. So if you think about what a yellow pigment is doing, it's obviously stimulating those same two cones in your eye, which means it cannot have any blue in it that's stimulating the blue cone in your eye. So we might think in terms of what yellow pigment is, it's allowing you to see the light that does not include blue. So when you mix a couple of pigments together, each one is responsible for subtracting one of the primary colors of light. So, for example, the yellow and the magenta. So we were just describing how yellow is the absence of blue, and in a similar way, magenta is the absence of green. So when you mix the yellow and the magenta together, you subtract those two colors, green and blue, and what are you left with? Well, you're left with only one color of light, and that is red. So that particular cone will be stimulated in your eye, and your brain will say you see red. And so that's why we say yellow pigment plus magenta pigment will make a red pigment. And in a similar way, a cyan and a yellow will make green pigment, because the yellow will subtract or absorb the blue light, and the cyan will absorb the red light, leaving only green. And then the third combination would be magenta and cyan, which subtracts the green and the red respectively, and you're left with what we call blue. So be comfortable creating this color diagram for pigments, just like you did for the primary colors of light. And of course, if you mix all three of the primary pigments, yellow, magenta, and cyan, they each subtract one of the primary colors of light, and they leave nothing left to stimulate the eye. And so we would call that no light at all, or sometimes black. So if you use these particular diagrams, I think it'll help you through most of the questions in MOP 6, and you'll be applying that also in MOP 7. So good luck, and let me know if you need any additional help.